Hello friends, this is Sudheer studying B.Tech first year in JNTUACEA Anantapuramu. Now I am going to discuss about a topic called binary tree. A binary tree is a special type of a tree which contains maximum of two children. One children is known as left child and other children is known as right child. In binary tree, a node can have 0 or 1 or 2 children but not more than 2 children. In the given example, A is root node and B and C are subnodes of A, and A contains two nodes. That implies A is called binary tree. Like that, B, C, D also have two child, so they are called binary tree. In a binary tree, the elements are arranged from top to bottom and left to right, and here we can see the time complexities of binary tree. Number 1, search operation. Its time complexity is O of n. Number 2, insertion operation. Its time complexity is O of 1. Number 3, deletion operation. Its time complexity is O of n. In the process of developing the binary tree, there we can have a special type of binary tree known as binary search tree. In binary search tree, smaller values in left subtree and only larger values in right subtree. That implies smaller values are in the left side and greater values are in right side according to the rules of binary tree. In the given example, 25 is a root node and 20 is placed left side of the root node because 20 is a smaller value, so it is placed in left side, and 36 is a greater value than the root node, so it is placed right side of the 25. And here is an important thing, every binary search tree is a binary tree, but every binary tree need not to be an binary search tree. Now come to the operations on a binary search tree. The following are performed in the binary search tree. Number 1, search operation, and number 2, insertion operation, number 3, deletion operation. Come to search operation in binary search tree, and its time complexity is O of log n. The following steps are taken to search an element or node in a tree. First, we have to analyze the root node of the binary tree, then compare the both nodes. If they are matched, the given node is found and terminate the function. If they are not matched, then we have to check the element is small or larger than the node value. If the element is smaller, then it is placed on the left subtree. Otherwise, it is larger, then it placed on right subtree. Repeat the same process until you have found the leaf node. If you found the leaf node, then element is found and terminate the function. If you not get a leaf node, then element is not found and terminate the function. Coming to the insertion operation in binary search tree, its time complexity is O of log n. In this operation, a new node is inserted in the leaf node. First, we have to create a new node and set its right and left to null. And the priority thing is, first we have to check whether the tree is empty or not. If the tree is empty, then we have to set a new node to it. If the tree is not empty, then we have to check the greater and larger differences between the nodes. If the new node is smaller, then it is placed on the left side of a tree. If the new node is larger than the node, then we have to move to the right side. Then repeat the steps until we reach the leaf node, that means reaching to the null. Finally reaching to the decide node, then you can insert your new node. If it is small value, it is placed at the left subtree. If it is greater one, then it is placed at the right subtree. Coming to the deletion operation in binary search tree, and its time complexity is O of log n. There are three cases rises in the deletion operation. Case 1 is deleting a leaf node, Case 2 is deleting a node with one child. Case 3 is deleting a node with two child. Case 1, deleting a leaf node. In any deletion method, first we have to search our desired node whether it is in the tree or not. When we find that our node, then we can use the free function and terminate the function. Number 2 case, deleting a node with one child. In this also searching operation is primarily done. In this only one child is there, so we have to create a bridge between a parent and a child node. Then we easily find that node and we can terminate that node using a free function. Then coming to the deleting a node with two children, in all three cases searching an element is done primarily because it is an important thing. In this node we have two children, so we have done opposite to the binary search tree, that is larger node in its left subtree or the smallest node in its right subtree. Now compare the both and delete the node which we have found in the above step. When you find that node, then delete the node. Here is an example which construct a binary search tree by inserting the following sequences of numbers. First taking root node as a 10, then following we have inserting a 12. 12 is a greater than 10, so it is placed right subtree to the root node. Then again inserting 5, 5 which is a smaller one than the root node, so it is placed left side of the root node, that is left subtree. Then again insert the 4, 4 is smaller than 10, so it is placed at left side, but there is a 5 which is greater than 4. For the 4 we can take 5 as a root node, and so it is smaller than 5, so it is placed at the left side of 5. And again insert the 20. 20 is greater than 10, so it should be placed at the right side of the root node. In that 12 is also there, which is a smaller value than 20. So here we are taking 12 as a root node and placing the 20 on the right subtree. Like that we are inserting 8, 7 and 15. So we see 15 which is greater than 10, so it should be placed at right subtree. By seeing the right subtree, there is 12 and 20. Going to 20 which is greater than 15. So we taking 20 as a root node, that implies 15 is placed at the left subtree. Then coming to the last insertion, that is 13. 13 which is greater than 10, so it should be placed at right side of the root node, and it is smaller value than 15, and taking 15 as a root node, so it is smaller than 15, it will be placed at left subtree. Like that we can insert the values so easily in a binary search tree by following three rules, that which are if the insert node is smaller value than the root node, it is placed at the left subtree. If the inserted value is greater than root node, then it inserted at the right side of subtree. Like this, binary search tree is constructed by the sequences of numbers. So finally, thank you for this opportunity. Hope you understand well.